Welcome to Read Along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 5.2.7. So here we're just kind of summarizing basically what we've been talking about the whole time. In order to solve a system, we were just running through, we were just taking this A, B and putting it into a map. And the output of that map was the solution. Well, we got to build that map. Well, the way we build that map is we just need to know what the image of E1 and E2 is. This is like E1, the thing that should satisfy this. Now, if we satisfy this, we showed that we get a well-defined map and that it's an isomorphism, exactly what we want. Okay, and similarly over here for E2, so we get where this is sent, where this is sent. We say A times it, B times it, and we end up getting the solution overall for the congruence, for this congruence right here. All right, so that's the basic idea. So maybe we should talk about how we actually solve these little systems right here to figure out where E1 should go and where E2 should go. Let's do that with an example down below. Okay, I'm going to go down to example 2 right here in this subsection here. So, okay, so we're solving this system right here. And notice we have to have that 5 and 12 in order for this isomorphism to work. We need that 5 and 12 don't share any common factors, and they don't. So we're good to go. So we first look for the solution to this system right here, and then that system. So E1 bar is this system. So what do? Well, we need to find something that is 0 mod. Remember what the mods were here in this case. The blue bar is referring to 12, mod 12 though now, and the red bar is referring to mod 5. So this tells us right here that we want something that's 0 mod 12. So that means it's a multiple of 12. So we want some multiple of 12. That's what that means. That means some multiple of 12. What does this mean? This means that when we mod this product, the product of whatever we have, when we mod it out by 5, we should get 1, which means this multiple right here needs to be the inverse of 12 mod 5. That's pretty much all. So just 12 inverse mod 5. So the way we get our solution is pretty simple. Here we take the mod, so this is 0 mod 12. So we take the mod here, the mod number on this congruence right here, 12, where we see a 0. So we say 12, and then we just simply multiply by its inverse, mod the other guy. So we take the one where we're 0, and we take that mod number, which is 12, and then we multiply by the inverse of itself, mod the other guy, 5. Okay, so the inverse of 12. What is the inverse of 12? Mod 5. Well, 12 mod 5 is 2 mod 5. The inverse of 2 is 3. Let's see, it's right here. So it's 3. So therefore, we just say 12 times 3. 12 times 3 is 36, and 36 definitely satisfies this. You can check it. It's 1 mod 5 and it's 0 mod 12. So 36 is our magic number here. Now, we can also write it as negative 24 if we like as well. Mod 60, they're the same. Okay. All right, so let's keep going. So that was the solution to that system. Now let's look at the solution to the next system, 0, 1. Let's see how we're going to do this. So first of all, since we have a 0 right here, we need to find something that is 0 mod 5, so multiple of 5. So multiple of 5. Go to where the zeros are. That tells you where to start with multiplying. Then the 1 tells you where to finish with multiplying. Finish by multiplying by the thing that inverts everything you multiplied for the zeros. So especially if we had more congruences here and we had more zeros going on, we'd simply take all those mods multiplied together, and then we would just finish it out where the 1 is by multiplying by the inverse of all of that in that one mod where the 1 is. Okay, so we have 5 multiplied by the inverse of 5, mod 12. Okay, so the inverse of 5 mod 12, so we can think, we don't want to multiply by something that shares a factor with 12, so we can't do 2 because that would give us, because that's a factor of 12. So we have to think maybe like 3 is a factor of 12, 4 is, but 5, that's like the first thing we can really do. And it actually ends up being the inverse itself. So 5 times 5 is 25, which is one more than multiple 12, so that works. So 5 times 5 gives us 25, and that's the solution to that system. So we now have the solutions to those systems, and those are precisely the images of E1 and E2. So then how do you solve the system? The original system that we had, which was different. Let's remind ourselves what it was. It was this one with a 2 and a 3. So we just basically say 2 times the first solution times 3 times the second solution. So just like this, 2 times the first solution, negative 24 bar, which was also 36 bar, plus 3 times the second solution right here. And then putting those together, we get 27 bar. So that means that all the solutions to this congruence are, well, where do they live? They actually live when you multiply these mods together. So 5 times 12, right? 5 times 12, this is 60. So this is the isomorphism we're working with, where we multiply those two guys together, and they didn't share any common factors. So this is a good working isomorphism. And so we want everything in this fiber mod 60. So 27 plus any multiple of 60 will give you a solution to that congruence, and you can write it this way or this way. Okay, one more system. All right, what are we doing when we have 3? Well, it's the same basic idea. So first of all, we want to do the image of E1. Now E1 has a 1, 0, 0, so 2 zeros down here, and maybe we should write this out. Okay, so E1, that's what this, so we want to look for the solution of E1, and that's what this blue is doing right here. So imagine 1, 0, 0. So we want to see the 2 zeros. 2 zeros denote these mods. So we start with multiplying those together, 7 times 13. Then we need to multiply that by something that is the inverse of 7 and 13 in mod 5 arithmetic, which represents the 1. Okay, so we need to find the inverse of the product 7 times 13 in mod 5 arithmetic, and it looks like 7 times 13 ends up being so 70 plus 21, so 91, which is 1 more than a multiple of 5. So the inverse was just 1, so we just multiply by 1. That's nice. Okay, then what about here? This is like E2. So this is like E1. E2 is like 0, 1, 0. So you take the 0 here and here. That would be like to take the mods, the 5 and the 13. You multiply those together, 5 times 13 right here. And then we multiply by something by its inverse, mod 7. Okay, so think about 5. So think about that. 5 times 13 mod 7. Well, we can think of 13 mod 7 as negative 1. That might help us a little bit. So this is really negative 5 mod 7, which is negative 5 mod 7 is the same as 2 mod 7. So what's the inverse of 2 mod 7 is really what we're looking at right here. And negative 3 will work because 2 times 3 is negative 1. So just make it mod 7. So because it's 6, and so just make it negative and it would work. So then we'd get this. This is the inverse mod 7 of that. Now let's look at the next part. Okay, so for the next part, we're doing E3. Now E3 is like 0, 0, 1. Okay, so look at where the 2 zeros are right here. Those work with the mods 5 and 7. So we're multiplying 5 and 7 together. And so we multiply 5 and 7. And we want to find the inverse of that. in the mod. So E3, for E3, we're looking at the last guy, which is 13. So mod 13. The mod that 1 refers to is 13. So we want to find the inverse of 5 times 7 in mod 13 arithmetic. 5 times 7 is 35. And let's see, if we multiply 13 by 3, we get 39, which means this is like -4 mod 13. So we want to find the inverse of -4 mod 13. Well, if we multiply -4 by 3, we get -12, so that would work. Yes, so it's right there. 3. Okay, so the inverse of that is mod 13. So we have that. So if we add this up and consider it mod the product of all the mods, 5 times 7 times 13, that solves the system. So 157 would solve the system, and you can add by any multiple of 5 times 7 times 13 and get another solution, but it's just one solution per chunk when you're modding out by that. Thanks for watching.